So we continue activity 2.1 with example 6. Here we have a product to a power. So the quantity x times y cubed can be written as the quantity x times y times the quantity x times y times the quantity x times y, right? Basically the 3 is saying we're going to repeat this multiplication 3 times. And then when we group the x's together and we group the y's together, we're left with x cubed times y cubed. And then they give us a definition down here, okay, product to a power. It says to raise a product to a power, raise each factor to that power, right? So my factors are a and b, my power is n, so I'm going to raise a to the n and b to the n. Right? In this case, we raised x cubed, or x to the third, and y to the third. So let's try a few problems. So problem 22, we have 9y squared, so that's the same as saying 9y times 9y. Or we could say 9 squared times y squared. So here you see 9y times 9y equals 81y squared. Another way to look at this problem would be to raise each factor to the power, so 9 squared times y squared leaves me with 81y squared. So either way would work. I probably prefer this method here, right? Raising each factor to the power. Let's take a look at 24. We could think of 24 as repeated multiplication, right? Negative 2x times negative 2x times negative 2x, right? We do the multiplication 3 times to get negative 8x cubed. Or we could take each factor, the negative 2, and raise it to the third power. And we could take the x and raise it to the third power. And we're left with negative 8x cubed. Let's try 26. So again, I start by raising each factor to the second power. Then I clean this up, and you're left with 16x squared y squared as your final answer. When we work with 28, again, I'm going to raise each factor to the third power and clean up wherever I can, right? Negative 3 times negative 3 is positive 9, times negative 3 is negative 27, and then we are left with the a cubed x cubed as for my final answer. Let's give number 30 a shot. So for number 30, I first handle what's in the parentheses. So I'm going to raise my 2 to the third power, the a to the third power, and the h to the third power. And then I'm going to try and clean this up a bit. So think of this as this 2 cubed is the same as saying 8, right? 2 times 2 times 2 is 8. And 8 times this negative 2, that's where the negative 16 comes from. Right? This negative 16 comes from negative 2 times 2 times 2 times 2. Then we have the a squared times the a to the third. So if we add the exponents, the 3 plus the 2, give me my 5. And then we have h to the 1 times h cubed. So the 3 plus 1 give me my 4. Next topic, we're going to try quotient to a power. So with this quotient to a power, we're dividing x divided by y, and we're raising it to a power, right? So this is division raised to a power, or quotient to a power. Again, this x over y raised to the third is the same as really doing repeated multiplication and repeated division, right? So we have x over y times x over y times x over y. And if we do the multiplication straight across the numerator, we have x cubed. Multiplication straight across the denominator, we have y cubed, and that's my final answer. And of course, they gave us a rule down here. If I have a over b raised to the n, I simply can think of it as I'm raising each item, the numerator and the denominator, to that power, right? So my numerator is a, so I have a to the n over b to the n. So let's try a few examples. So problem 32, we have this negative 2 divided by y raised to the third power. So the long way to solve this problem would be to actually do the repeated multiplication, right? The negative 2 over y times negative 2 over y 3 times. If I multiply all the negative 2's, I get negative 8 on the top, and all of the y's give me y cubed on the bottom. Let's make that a little bigger. Okay. There's another way to handle this problem. The second way to handle this problem would be to, again, take each of the factor, right, the numerator and the denominator, take the numerator and raise it to the power, so that's negative 2 to the third, which is negative 8, and take the denominator and raise it to the power, so you get y cubed. Let's try number 34. So for 34, there's really not much to do here. Just we're going to take the numerator and raise it to the 7th power, and take the denominator and raise it to the 7th power, and that's pretty much it. We're done. Let's try number 36. So for 36, you'll see I take the 3, I raise it to the 3rd power. The a, the x, I raise them both to the 3rd power. The y and the z, I raise to the 3rd power. And then I simplify wherever I can. I can't really do anything with the letters, but the 3 cubed becomes 27. And here's my final answer. Let's take a look at 38. So for 38, if you take a close look, you'll notice our base is the same. Our base of the exponent is negative 2 over x, right? So we have the same base. So if I use the multiplication property, I can add the exponents, right? When we have the same base, we can add the exponents. So I'm going to add the 2 plus 3 on this base of negative 2 over x. So now you can see I'm left with the negative 2 over x raised to the 5th power, which cleans up nicely to become negative 32 over x to the 5. Right? We take x and we raise it to the 5. Negative 2 raised to the 5th power is negative 2 times negative 2 times negative 2, 5 times. Ultimately, you get negative 32. The next topic is going to cover a power raised to a power. So the power to a power property, well, essentially, if we have a base raised to an exponent, and that's raised to a power, we can multiply the exponent and the power. So when you look at this problem in example 11, where we're asked to simplify x squared cubed, well, if we multiply the 3 and the 2, we end up with this x to the 6th. Another way to look at it is, well, it's repeated multiplication. So that's x squared times x squared times x squared 3 times. And then we know when we multiply the same base, we just add the exponent. So 2 plus 2 plus 2 is 6. So let's look at a few practice problems. Problem 42. Well, there's not really much to do here. We're going to multiply the 4 and the 3 to get 12. So y to the 12th should be our answer. Problem 44, I'm going to take this negative 5 and raise it to the 2nd power. And then I'm going to have the y to the 4th times 2 to get y to the 8th. So here you can see me squaring the negative 5. 4 times 2 is 8. So negative 5 times negative 5 is 25 y to the 8th. Problem 46. Not really much to do here, right? We're going to multiply the 2 and the 3 to get the 6. Again, this is really b raised to the 1. If there's no number for an exponent, it's a 1. So 3 times that 1 is 3. So I'm left with a to the 6th over b to the 3rd. Let's try 48. So in 48, this is 4 raised to the 1. We multiply the 1 and 2 to get 4 squared. The 3 and 2 give me 6, and the 2 times 2 gives me 4. And we know that 4 squared is the same as 16. So here's my final answer. And the last problem is number 50. So for 50, first I'm going to simplify what's in the parentheses, right? 12 divided by 4, we know that's 3. X to the 8 over x to the 5, well, if I do 8 minus 5, I'm left with the 3. So this inside the parentheses becomes 3x cubed raised to the 3rd. Now we can use our product to a power property. So we're left with 3 cubed times x to the 9th, and 3 cubed becomes 27, so we're left with 27x to the 9th.